Greetings, Professor. We are Group 7 and we would like to present about our final group presentation for the course Social Data Mining Techniques on the topic Date Default Prediction. Our team member consists of 3 members, Jashanpreet Singh, Benson Fernandez and myself, Priyesha Sharma. In today's world, lending is one of the leading businesses around the world. Even though it makes profit for the financial companies, some do incur losses due to lack of information about the current trends of data management. We explore the power of advanced analytics in identifying the risk factors and prioritize low-risk lending segments and enhance overall loan process. The primary purpose of a project is to enhance the efficiency and accuracy of loan approval processes within the banking industry. We aim to achieve this by leveraging machine learning models to predict loan defaulters. By doing so, we address the critical need for accessing the creditworthiness of loan applicants, ultimately reducing the risk for lending institutions. Our possible clients for this project can be financial institutions and banks. They can use these models to assess loan applications and monitor existing loans, reducing the risk of defaults and financial crises. Risk management teams, they are responsible for assessing and mitigating risks associated with lending. Loan applicants, potential borrowers are also part of our audience. Our project indirectly benefits them by promoting fair and accurate loan approval process. Investors and stakeholders. Investors and stakeholders in financial institutions can use the results of a project to evaluate the risk associated with their investments. Data scientists and analysts, professionals working in data science and analytics roles can gain valuable insights from our project. Moving on, we have our data flow diagram. The process begins with collecting data from loan applicants. This data is stored in a raw data repository. The raw data is then cleaned and pre-processed to correct errors, handle missing values, and make the data suitable for analysis. The clean data is stored in a clean data repository. In this feature selection and engineering phase, relevant features that contribute to the prediction are selected and new features may be engineered to improve the model's performance. The dataset now with selected and engineered features is stored in a feature-engineered data repository. Then the prepared dataset is used to train machine learning models. The trained models are stored in a model repository. The trained models are then evaluated based on performance metrics and the best performing model is selected as the final model. The final model is deployed to make predictions on new data. The prediction results are stored for further use. The prediction results are then reported to business users for decision making. We are going with a structured data source for this project, as most of the bank databases are maintained as tables instead of unstructured data. We retrieve the dataset from Kaggle. This dataset spans the years 2007 through 2013 and pertains to loans applied for by customers in the United States. This dataset spans the years 2007 through 2013 and pertains to loans applied by customers in the United States. The dataset comprises a total of 119,147 records and encompasses 43 variables. It's noting that this dataset contains a substantial number of missing values. We have a total of 14 quantitative and 29 qualitative variables. Additionally, many of the columns can be deemed irrelevant, excessively sparse, or lacking in informative content. Let's move to the data cleaning. We use Python for data cleaning. First, we check the file for missing values. We removed irrelevant columns that do not contribute to our project. We replace the null values with zeros after checking their effects. We also dropped some columns that contain too many missing values. Then the clean data is checked and exported into a CSV file. Let's move to data analysis. As observed, a significant portion of applicants have sought loans for the purpose of date consolidation. Interestingly, these applicants have exhibited the highest default rate, approximately 1.73%. This trend may be attributed to their initial intent, which was to secure funds for repaying existing credit card bills or previous loans. Out of all applicants, 2.76% have experienced loan repayment issues, while more than 97% have successfully repaid their loans in full. Considering that this dataset contains records from a period during the US recession, characterized by a surge in bad loans without proper verifications, it's evident from Figure 4 that a substantial number of loans were not subjected to verification. This situation is concerning because prioritizing applicant verification should always be a fundamental practice. As previously mentioned, during the recessionary period, some customers just availed loans to increase their credit score. They are low risk customers, and this can be found using their current salary along with their home ownership. Next, I will hand over to my teammate Benson, who will walk you through the machine learning process. Thank you.
Thank you, Priyasha. My name is Benson Fernandez, and I will now walk you through the machine learning process. So, for machine learning, we have used the tool RapidMiner, and we have selected four models to work with. They are random forest, logistic regression, gradient boosted trees, and decision tree. So, first, let's look into the random forest model. So, random forest model is actually an ensemble model combining multiple decision trees. It improves prediction accuracy and controls overfitting. It also uses a randomization process to ensure a diverse set of classifiers, and it is robust against noise and capable of handling complex datasets with numerous variables. And it is also important that it is frequently used in loan default prediction often. So let's look into the model that we created in RapidMiner. So initially, we have a read CSV that reads the source data file, and then we have a nominal to numerical operator which converts categorical data into numerical format that can be used by machine learning algorithms. And then we have the select attributes that selects a subset of attributes from the original data set. And we also have the set role operator. So what this set role operator does is it has uh, a feature called target role. So we assign the label uh, of the target role as the one that we need to predict. So in our case, we have the loan status that we need to predict. So we set it as the label. And then we have the operator called split data, which splits the entire data into a ratio. So for this, we have used a ratio of 70 is to 30. So we have given it a 0.7 and 0.3. And then we have connected the training data to the random forest and the test data to apply model. So what it does is the model data from random forest, that is the 70% data, also goes to apply them to the apply model, and the 30% of test data is executed based on the 70% data, and then the results are generated. Then the results from the apply model is then sent to the performance operator, which evaluates the performance of the model using predictions like predictions made on the test set. It will give the performance metrics accuracy. And once we run this, populated over here, and we have to go to the performance vector to go for our accuracy score. And here the overall accuracy of the model is 97.24. The overall accuracy of the model is 97.24, which suggests that the model correctly predicts a loan will be fully paid or defaulted 97.24% of the time. While the accuracy is high, it is important to note that the precision and recall for predicting default is also high, but there are no values found here. It's just zero over here. So that is one thing that we needed to consider. So moving on, let's go to the next model, which is our logistic regression. So logistic regression is a statistical model for estimating the probability of a binary outcome, and it is ideal for predicting loan defaults as well. It is valued for its simplicity, efficiency, and interpretable coefficients. And coefficients can be translated into odds ratio as well. Now let's look into the model for for logistic regression. So let's go back, and here we have the model for logistic regression. We have the similar setup, like where we have a read CSV, the select attributes that selects only a subset of the columns that we need, and then the set role operator that has the loan status as the label, and then we split the data into 70 is to 30 ratio as usual, and then we connect the training data to the logistic regression operator and the test data to the apply model, and then the model data from the logistic regression towards the apply model connector, and then the output from the apply model gets to the performance where the accuracy score is calculated. And let's run it and see. So here we can see for the logistic regression, we have an accuracy of 98.03, which suggests that the model also correctly predicts whether a loan will be fully paid or default by 98.03% of the time. And it is important to note that the precision and recall for predicting predicting the default status quite low than the fully paid status. So yeah, we are having the class precision to be 76.92 for default, and true default class recall for true default to be 40.61 percentage. So moving on, let's go towards our next machine learning model, which is the gradient boosted tree. So gradient boosted tree is also an ensemble learning technique that builds trees sequentially, and it minimizes predictive errors by focusing on accuracy. And it is suitable for handling nonlinear relationships in data. It is often used when performance is a priority in predicting loan defaults. Now let's look into the model in Rapid Miner. So we go to design, and we select gradient boosted tree. So again, we have a similar setup. Though we have the read CSV, select attributes, set rule, split data as same as the logistic regression, and then we replace the logistic regression by gradient boosted tree operator. And then we have, as usual, we have the apply model and performance. So in this, let's run this model and see. So yeah, here we are getting an accuracy of 93.44 percentage, which clearly is lower than the logistic regression and random forest. And while the accuracy is a little bit lower, the model also struggles with accurately predicting the defaults as well. It has a class precision of 29.33 percentage only for predicting defaults. Next, we'll move on to the next and final machine learning model that we have. It's called the decision tree. It's a flowchart like model that uses branching methods, and it illustrates every possible outcome of a decision, and it provides a clear visualization of decision making process. It's simple and interpretable, making it useful for stakeholders. And now let's look into the model that we created in the Rapid Miner. Let's open decision tree. We have the similar setup. As usual, we have the read CSV, select attributes, set role, split data, and then we have the apply model, decision tree, followed by the performance as usual. Well, let's quickly run this. Yep, it's run. Here we can see the accuracy to be 97.41 percentage, and still the prediction for predicting defaults is 54.7475 percentage. It is not as low as gradient boosted tree, but still it is quite low when compared to logistic regression. Now, let's move on to the model selection that we have for a loan debt default prediction. The model that we are going to select is the logistic regression. Let's explain why we selected this model. For a loan default prediction model, we often prioritize the ability to accurately predict defaults due to the associated costs. Precision of default is important because a low precision means the model predicts many non-defaulters as defaulters. Recall of default is also crucial because a low recall indicates that the model fails to catch actual defaulters, which could result in a financial loss. The logistic regression model has a high overall accuracy and a balanced precision and a recall for the default class. The gradient boosted tree model has also lower overall accuracy, but its recall for default is very high, but it's 100% only because the predicted and the actual was zero. Then the decision tree model also has a high overall accuracy, but still it had a low accuracy for predicting defaults. Uh, just a thing like the we say the word default is for people who default the loan, like who are unable to pay their loans. So please keep that in mind. And finally, the random forest also would need its metrics to be evaluated as their prediction for defaults is quite low. Then, based on these considerations, the logistic regression model seems to be the most balanced with the highest accuracy and a good trade off between precision and recall for the default class. However, this recommendation could change based on the business context and future data as well. Now, I will hand over the presentation to Jashan, who will walk you through their Power BI dashboards.
Thank you, Benson. I am Jashan P. Singh and I will be presenting the next part of the presentation. For our project, we have also created a Power BI dashboard which can be used for some quick analysis and viewpoints. The first page is a landing page that can be used to navigate to any of the dashboards. We have a bar chart that describes the loan status by purpose, and from the chart we can see that the debt consolidation is the highest purpose for any availing loan. Next we have a pie chart and a column chart. The column chart has the number of members by the employment period, and from the chart we can see that the highest number of customers are having the range of employment around 10 plus years. We have other slices and filters available that can be used for in-depth information about loans. Next we have another dashboard which gives details and is filled with KPIs about the information of loans based on the customer. We have average annual income by employment length, a scatter plot containing average of applied loan amount and the average of loan amount sanctioned by the bank. For our final dashboard, we have analysis specific to details about customer care. We have a line graph that deals with the loan against the interest rate, a column chart that describes the type of home against their salary, and another scatter plot of members while comparing information of total loan availed versus total payments. Moving on, we can discuss about the insights and analysis. The majority of individuals who defaulted on their loans had originally applied for them with the intention of repaying existing debts, particularly credit card bills. Over time, there has been a notable decline in the number of loans that were approved without proper verification. Prior to US recession, there was a significant surge in the number of loan defaulters. Some loan applicants seek loans solely to enhance their credit scores. These individuals are considerably low-risk customers since they already possess a stable source of income. Political events such as presidential elections in 2012, characterized by policy and tax reform uncertainty, tend to discourage people from applying for loans. Next, we have recommendations for our audience. Based on overall evaluation, the logistic regression model emerges as the most effective solution for addressing this problem. When it comes to education loans, there is notably a lower default rate, making it an area where banks can allocate more resources and attention. For applicants seeking loans primarily for debt consolidation, continuous monitoring of credit card related factors including credit scores and other relevant parameters is essential. Prioritizing short-term loans is advisable given their historically lower default rates and reduced risk. The setting of interest rates should strike a balance, ensuring that they are not excessively high, which could pose difficulties for customers in meeting their repayment obligations. Banks might explore the possibility of offering insurance coverage for loans in the event of the applicant's demise. This not only provides a safety net for the applicant's family but also presents a business opportunity for the banks to collaborate with insurance agencies. And finally, let's summarize the analysis. The predictive modeling conducted in this study have illuminated key strategies for mitigating loan defaults and optimizing lending practices. The logistic regression model emerged as the most effective tool for risk assessment, emphasizing the importance of data-driven decision-making in the lending process. Notably, education loans exhibited a lower default rate, warranting increased focus from financial institutions. Through background checks, regular credit monitoring for debt consolidation applicants, and the prioritization of short-term loans were identified as essential risk management practices. Careful consideration of monthly installment amounts and maintaining reasonable interest rates are crucial to ensure borrowers can meet their obligations. Additionally, exploring insurance coverage opportunities for loan applicants in the event of their demise represents a potential avenue for risk mitigation and new business ventures. By implementing these insights, lenders can enhance their loan approval processes and create a more secure lending environment. Thank you for your time. This is it from us.